Okay. Why are you so giggly?
I don't know. It's just too much pressure.
It's too much pressure. Okay, this is the targeted tutoring session for groundwater and surface water in a watershed. We're just going to go through the basic ideas. You guys good? Everybody has notes taking paper? Okay. We're just going to go through it quick as we can. What's groundwater? This is a lot of writing. I just sort of Googled this PowerPoint. Groundwater is water under the ground. It's stored in an aquifer. I'm not going to read all this out loud because that seems kind of crazy. Yeah, groundwater is water that's stored under the ground. Ugh. I need to blow my nose on this camera. It'll be terrible. I'll just wipe it.
Underground, right?
Yeah, groundwater is stored underground. Cannot see it. You can dig a well and find it, but it's underground. Okay, we're gonna move on. You guys don't have to write all this down. This isn't. You should already know this. You don't have to write down groundwater is under the ground if you already know that. Okay. Okay, so here's just a really awesome picture of groundwater in a watershed. So your watershed's up here. It's got rain coming down on it. Under the ground is groundwater. And you can see there's wells. Here's an agricultural well to irrigate agricultural lands. Here's an injection well where they pump water back into the aquifer. Here's a municipal industrial supply well, and you can see there's a really big dip under there where the water has been pulled out and it's created a dip. So yeah, the water cycle, it's very complicated. So there's surface water, which is on top, you can see it. Groundwater is under the ground, you can't see it. You guys good so far?
Yeah.
Okay. What's a watershed? It's the land area.
Could you come to the front desk, please? Baby, Lepa, come to the front desk.
It's Baby. You know Baby?
I don't know.
Here.
I don't know her. She's an awesome name though, Baby. The watershed is the land area from which the surface drains into a channel or into a river or into a common area. Watersheds are also called drainage basins. It's just where all the water falls when it rains, it all drains to the same place. Okay, so we should already kind of be familiar with what a watershed is. Okay, here's just another watershed diagram. It shows the boundary line here, this like dotted black line, where when the rain falls, part of it will slide over here, and part of it will go to another different watershed. So those are called watershed divides. This little label right here where it says riparian zone, that's just any zone where the water meets the land. That's a riparian zone. And water obviously follows the trail of gravity, so it goes from high points to low points, which is why it ends up in low points like rivers and oceans. This is our watershed. We live right here, just south of the Trinity River, right there on the border between Tarrant and Dallas County. And this is the Trinity River watershed. It starts up here in Clay County, and it goes all the way down to the Gulf of Mexico. So at some points it smells kind of bad. And the reason that it smells bad and it's polluted is because it goes through this huge industrial area. Like this whole Collin, Denton, Tarrant, Dallas County, this whole thing right here is just a big city, suburbs, sprawling land of developed surfaces, and we'll talk about why that's kind of bad for the watershed. But it gets seriously polluted right in here, and then right in here, like this is sort of a very not very populated part of Texas. Okay, so human activities that can affect the water quality in a watershed. Agriculture is a big one. Farmers put a bunch of fertilizers on their field, and that eventually washes into the waterways and creates algae blooms or phytoplankton blooms in the Gulf of Mexico, which can cause those dead zones. Urban development and industry. When you pave surfaces, like natural ground is dirt and it's grass or it's trees, and so when it rains, the water soaks in there nice and easy. When you pave it with roads, the water does not soak in through the roads very easily, so that causes a lot of runoff problems. Drainage of low-lying areas, the construction of levees and dams will change the way the water naturally flows, and the removal of vegetation from floodplains. So in a floodplain, that's just like the area around the river where when it floods, the river goes into that area. If you remove the vegetation, then the river can erode a lot of the soil away, which is kind of bad for that area. So we'll talk about each of these in a little bit more detail. Agriculture, irrigation. A lot of times farmers have to water their crops because we don't get enough rain, and so they pull water up out of the aquifers, which causes the groundwater levels to lower. And they also apply a bunch of stuff to the crops to make them awesome. Chemicals, pesticides, fertilizers. You don't want to buy your corn with a bunch of bugs in it, so they had to put pesticides on it to kill the bugs. You want your corn to be nice and big and healthy and yellow and awesome, so they had to put a bunch of fertilizers on it to make it grow as big as possible, as quickly as possible. So they just put a lot of stuff into farming that is not necessarily good for the water. Yeah. When those fertilizers get into lakes, they can cause algae blooms. When the fertilizers are eventually washed into the oceans, they cause those large phytoplankton blooms, which cause those dead zones. Urban development. I love this picture of it. If you guys can pay attention to this. So this picture right here, the first one, is with no development. So this is no houses, no streets, no people. It's just trees, dirt, ground. And if you look, it says 0% impervious surface. So what that means is that 0% of the ground has been paved or is impervious. That means water can't soak into it. So water can soak into 100% of the ground. And so if you look at this little part right here, it says 0 to 20% runoff and 80 to 100% infiltration. So runoff is when water runs along the top of the ground, and infiltration is when the water sinks into the ground. So if you've got a lot of unpaved surfaces and you've got no impervious surfaces, then most of that water is going to soak into the ground. So then you can move up to this next level here. This is low density residential. So this is houses that are on a lot of land and the houses are far apart. So this one you've got 10 to 20% impervious surfaces. So the impervious surfaces here would be what? Like, what are some of the surfaces that rain could fall on and not soak in? The sidewalk, good. What else? The roof. The river, no, the river is impervious. I mean, the river, the water's gonna just go directly into the river. When we're talking about impervious, we mean it can't soak into it. Like, it's not gonna go into the ground or into the river. So when water hits your house, it just rolls off the edge of the roof and it falls on the ground.
Oh.
Does that make sense? So that's runoff. So here you've got 10 to 20 or 10 to 30% runoff, which means you've got 70 to 90% infiltration. Still not that bad. Urban residential, this is pretty much what we live in. You live in just a regular neighborhood where you can see your neighbor's house out your window and it's pretty close to yours. That's 35 to 50% impervious surfaces, which means 40 to 70% of the water runs off and only 30 to 60% of it infiltrates and soaks into the ground. So what happens with this is that as you decrease the amount of water that infiltrates, you're actually decreasing the amount of water that's going back into the aquifer. So you're going to lower the water table in the aquifer. And you can see the impervious surfaces here. You've got a bunch of houses. You've got roads. And then you guys can see right here, there's like a little pipe. Do y'all see that?
Oh, yeah.
Okay, so since we live in neighborhoods where we have nice roads, usually they have those storm drains along the edges. So those storm drains eventually drain out of pipes like this called outlets. And the reason that we have to have those is because the water can't soak into the ground when it rains. It just runs off the road, so you have to have those storm drains to allow the roads to not get completely flooded. So it's a solution to the runoff problem, but a better solution would be to pave with more porous or permeable concrete. Like we saw that one video. Do you remember that video where the water just like soaked into the concrete?
Oh, yeah.
Oh, yeah, that one.
Big,
And that big water truck was just pouring the water and it just soaked into it. And then whenever you've got, like, when you're in the big city, commercial, industrial areas, almost 100% of the water is going to be runoff. 75 to 100% of the area is impervious, which means the water's not going to soak in. You're going to get very little water infiltration. You're going to have large water outlets pumping all that runoff out. Excuse me. The reason that the runoff becomes a problem is because as it's running off, it's eroding soil. So it's washing soil into the waterways, which isn't good for it. It's also washing off all the pollutants, all the oil and gas and trash that's on the road gets picked up in the rain and the runoff and carried away into the waterway. All right, dams. We didn't talk a lot about dams when we learned about watersheds, but I thought this was interesting. Dams are when you stop a river from flowing and it floods the area upriver of the dam, and it basically creates a lake, and then they control how much of the river they want to flow. Some of the benefits: it can provide irrigation water. It can provide water for drinking. The reservoir the reservoir is the lake. The reservoir can be used for recreation like boating and fishing. It can produce cheap electricity through hydroelectric power, which is down here. And it can reduce downstream flooding. So if you can control how much of the water comes out of here, then pretty much downstream of a dam it doesn't usually flood because they can control how much water is being released. The negative impacts of dams: when you build a dam, this area that floods because you're stopping the normal flow of the river is going to destroy the natural areas or people's homes or whatever that was there before you flooded it. You lose a huge amount of water through evaporation. You deprive downstream croplands and estuaries of nutrient-rich silt. So silt is like all of the particles that have been eroded and the river is carrying them down and carrying them down. When the river gets to a dam, all of that silt just builds up. And so that silt is necessary for the health of the river downstream, but it's not getting it. There's a risk of the dam failing and bursting and like everything flooding downstream. And it disrupts migration of spawning of fish. So like in Washington and places in Alaska and Canada, the salmon have to travel. They come in from the ocean and they swim up the river to spawn and lay their eggs. And if they come to a dam, then they can't get past it. And so it affects those fish populations. So that's just a couple different ideas on dams. They're probably not going to want to ask you too many questions about that. I just thought it was interesting. Okay, we're going to do a little critical thinking exercise. I'm not going to read this to you guys because my voice is kind of going out. Can y'all read that?
Us?
Yeah, y'all.
By ourselves?
Yeah.
Or do you want us to read it to you?
No, you can read it to yourself. I want you to read it and then answer it on your paper. Write between 3 and 5 sentences. And I think that's it. Okay, that's it. So I'm going to stop recording it. Okay, bye people who are watching this at home. We'll miss you. Discard.
Oh, that was so much fun.
Hold on, I haven't stopped it yet.
Oh.